Hello students, in this class we will learn about quadratic polynomials. Okay, so that means what is the general form of quadratic polynomial? Already we know the general form of a quadratic polynomial. In this class we will study about the zeros of a quadratic polynomial and how that zeros are related with the coefficient of x squared, coefficient of x and the constant term. Okay, so let us study about quadratic polynomial. General form of a quadratic polynomial is f of x equals to ax squared plus bx plus c, where a not equals to 0 and a, b, c are constants. Okay, already we know this is the general form of a quadratic polynomial where the strict condition is that a not equals to 0, because if a is 0 then there will be no square term and that expression will be a linear polynomial. Okay, that is why this is a strict condition, that is a not equals to 0 and this constant, they are a, b, c, all are some real numbers. Okay, now if alpha and beta are the zeros or roots of this quadratic polynomial, then by the factor theorem we can say that x minus alpha and x minus beta are the factors of the polynomial f of x. Okay, now if we choose two real numbers, they are alpha and beta, and if these two real numbers alpha and beta are the zeros of this quadratic polynomial f of x, then by factor theorem we can say x minus alpha and x minus beta will be the factors of this polynomial. Already we know what factor theorem states. In our previous classes we learned about factor theorem and its applications also. Okay, so x minus alpha and x minus beta will be the factors of this polynomial f of x. Their product, that means x minus alpha and x minus beta, will also be the factors of this polynomial. So the product of x minus alpha and x minus beta, that is x minus alpha into x minus beta, will also be the factor of the polynomial f of x. Okay. Now, so therefore, the polynomial f of x can be written as f of x is equals to k into x minus alpha into x minus beta, where k is a non-zero constant. Okay, if x minus alpha into x minus beta becomes the factor of this polynomial f of x, then we can write f of x by this way, that is f of x is equals to some non-zero constant k into x minus alpha into x minus beta. Okay. This imply f of x is equals to k into, by multiplying these two, we get x square minus of alpha plus beta into x plus alpha beta. Now, if we put ax square plus bx plus c in place of fx, then we get ax square plus bx plus c is equals to k into x square minus k into alpha plus beta into x plus k into alpha into beta. Okay. So this, from this relation we get some conditions comparing the coefficient of x square and coefficients of x square and x, and also the constant term from both side. Both side means from this relation. From this relation. From both side we get k equals to a minus of k into alpha plus beta equals to b, and k into alpha into beta is equals to c. This will give alpha plus beta is equals to minus b by k, and alpha into beta is equals to c by k. So these imply alpha plus beta is equals to minus b by k becomes equal with a. That is why alpha plus beta is equals to minus b by a, and alpha into beta is equals to c by a. Okay. Therefore, we can say sum of the zeros of a quadratic polynomial equals to minus of coefficient of linear term, that is here x, by coefficient of the square term, that is x, and product of the zeros is equals to constant term by coefficient of the square term, that is x square. Okay, so these are two relations. We get this relation from this derivation. Okay, that means sum of the zeros, that is alpha plus beta, is equals to minus b by a, where b is the coefficient of the linear term, that is coefficient of x, and a is the coefficient of the square term, that is here the coefficient, here the square term is x square and its coefficient is a. Okay, and product of the zeros is equals to c by a. C means the constant term and a means the coefficient of the square term, that is coefficient of x square. Okay, so this is the relation between the zeros of a quadratic polynomial and the coefficient and the coefficient of x square, coefficient of x, and the constant term. Okay, now we will verify this relation with the help of a problem. If x square plus bx plus c, where a not equals to 0, represents a quadratic polynomial, and alpha beta its two zeros, then we have alpha plus beta is equals to minus b by a, and alpha into beta equals to c by a. Okay, so we will verify this relation by an example. Find the zeros of the polynomial f of x equals to 2x square minus 15x plus 7. So find the zeros of the polynomial this and verify the relationship between the zeros and the coefficient. Okay. Solution. F of x equals to 2x square minus 15x plus 7 imply f of x is equals to, so this is a quadratic polynomial. When we want to find the zeros of this quadratic polynomial, then we have to factorize this. Okay, how we can factorize a quadratic polynomial? Already we learned about middle term factorization. So here we will apply middle term factorization to find the to factorize this polynomial f of x. Okay, so here the linear term is 50 minus 15x. So we have to write the coefficient of this linear term, that is 15, excluding its sign, with the sum addition or subtraction of two numbers. And how we get those numbers? Now, to find those numbers, first of all, we have to find the product of the coefficient of the square term and the constant term. So here the coefficient of square term equals to 2. Constant term equals to 7. Their product equals to 14. Two factors of 14 are 1 and 14, whose sum equals to 1 plus 14 equals to 15. Okay. So here we choose two factors of 14. They are 1 and 14, and whose sum is 1 plus 14 is equals to 15. Okay. There are so many factors of 14 like 2 and 7, but their sum will not give 15. That is why we choose two factors of 14 as 1 and 14, because their sum will give 15 and we require 15 for this middle term factorization. So 2x square minus 14 plus x minus of 14 plus x into x plus 7. 2x square minus 14x minus x plus 7. From these two, the common factor is 2x, and after taking out 2x as the common factor, the rest of the term will be x minus 7. And from this last two term, minus 1 is the common factor. So this is the factorization of this quadratic polynomial f of x. To find the zeros of f of x, we consider f of x equals to 0, which will give x minus 7 into 2x minus 1 equals to 0. So product of these two terms equals to 0, imply both of these 0 or one of these equals to 0. So that is why we can write x minus 7 equals to 0 or 2x minus 1 equals to 0. So this will give x equals to 7 and this will give x equals to 1 by 2. Okay. So therefore, two zeros of the quadratic polynomial f of x are 7 and half. Okay. So this is the way by which we can find the zeros of a quadratic polynomial. So to find the zeros of a quadratic polynomial, first of all we have to factorize the quadratic polynomial, and then we have to equal f of x with 0, and after this we will get an equation, and the equation becomes, here the equation is x minus 7 into 2x minus 1 is equals to 0. So since product of these two terms is 0, then we can say one of these term is 0 or both of the terms are 0, because product of 0 into any other number is 0, or product of 0 into 0 will give 0. Okay, that, and after equalizing this we get x equals to 7 and x equals to half. So we can say 7 and half are the two zeros of this quadratic polynomial. Okay. Now if we consider the zeros as alpha equals to 7 and beta equals to half, then alpha plus beta is equals to 7 plus half, which will give the LCM becomes 2, because LCM of 1 and 2 will give 2. So 7 to the 14 plus 1, that is 15 by 2. So sum becomes, that is alpha plus beta becomes 15 by 2, and their product, that is alpha into beta, is equals to 7 into half. This will give 7 by 2. Okay. So after finding the zeros of this quadratic polynomial, if we choose 7 as alpha and half as beta, then their sum, that is alpha plus beta, is equals to 15 by 2, and alpha into beta becomes 7 by 2. Okay. Again, if we compare the given polynomial f of x equals to 2x square minus 15x plus 7 with the general form of quadratic polynomial f of x equals to ax square plus bx plus c, then we get a equals to 2, b equals to minus 15, because minus 15x means plus into minus 15x. That is why b is equals to minus 15 and c equals to 7. Okay. So since f of x equals to 2x square plus minus 15x plus 7 can be written as f of x equals to 2x square 2x plus 7. Okay. So a becomes 2, b becomes minus 15, and c becomes 7. So therefore, sum of the zeros equals to minus b by a, that is coefficient of the linear term, that is coefficient of x by coefficient of x square. So here b means minus 15 and a means 2. So this will give 15 by 2, and product of the zeros equals to c by a, that is coefficient, that is the constant term divided by coefficient of x square. So here c means 7, a means 2. Okay. So previously we find sum of the zeros and product of the zeros. Sum of the zeros is equals to minus 15 by 2, and product of the sum of the zeros is equals to 15 by 2, and product of the zeros is equals to 7 by 2. And by using this relation, when we find sum of the zeros of this quadratic polynomial, then we get sum of the zeros is also 15 by 2, and product of the zeros is also 7 by 2. Okay. Thus we can thus our verification is completed. So thus our verification between the zeros and coefficients are completed. Okay. There is one more thing, students, that is when the zeros of a quadratic polynomial are known, then how we can find that quadratic polynomial. Okay. So if alpha and beta are the two zeros or roots of a quadratic polynomial, if alpha and beta are the zeros or roots of a quadratic polynomial, then the quadratic polynomial is f of x equals to k into x square minus sum of the zeros into x plus product of the zeros, where k is a non-zero constant. Okay. So if alpha and beta are two zeros of a quadratic polynomial, then the quadratic polynomial can be written as in this form, that is f of x is equals to k whole into x square minus sum of the zeros into x plus product of the zeros. That is f of x equals to k into x square minus sum of the zeros into x plus product of the zeros, where k not equals to 0 are constant. Okay. So This is the form by which we can represent a quadratic polynomial when its zeros unknown. Okay. In our next class, we will learn how we can apply these relations, that is the zeros of a quadratic polynomial in our problems. Okay.